start doing my little talk here. Good to see those of you that are gathered, and hope you can hear me above the Beatles noise from across the way. That's definitely a challenging thing to contend with. We haven't quite got the level of oomph here on our sound system to compete with that. First of all, a little bit about me. I come from the UK, as you'll have gathered by my accent. I also I've just flown over from my first granddaughter's first birthday party this last weekend. So I actually converted some PTP facts in terms of 25 frames per second video frames and audio samples of 48 kilohertz, just to look how many audio samples I've existed for. So I think that I made that 78,000 billion audio samples, and my granddaughter has had about 1.5 billion audio samples in her life at 48 kilohertz. Anyway, so that's a little bit about me. I spent 22 years working for British Telecom, heading up their broadcast R&D and deployment capability, and then joined Nevion, joined the dark side of Vendorland about 9 years ago. So that's my my heritage. So just wanted to sort of give due credit to the audio guys first to start here, to say the audio guys have done IP first. So I very much come from the work we do is very video centric, but the audio is obviously incredibly important, and it's great to see with the innovation of AES 67 how that was there first and led the way in terms of some of the principles that we've now adopted across the whole media industry for actually carrying audio. Now, I'm not going to boil the ocean here, but there's obviously lots and lots of different audio interfaces and standards, some very open, some more proprietary, that people are actually running with. But where I'm very specifically going to be jumping to for the next few minutes is talking about deployments with respect to ST2110 and the audio that's actually contained within there. Now, many of you will know that the AES 30, as it's defined, is very much based on AES 67, with one or two restrictions in operating points compared with AES 67, but very much they are akin. And similarly, the Dash 31 of the 2110 suite is based on some Rayner work to actually carry the transparent all 32 bits of the AES audio sample. So very much it's the audio heritage and the existing work that had already been done in the audio industry that's been ported into the 2110 suite for audio, and that's actually that's very exciting, and that's given us a good platform alongside everything else. It's worth saying, as you'll see here, the ST2110 suite itself is expanding as well, not just from those original 4 blobs at the top there, but also we're expanding to actually cover other things, including how to carry multi-part video, how to carry standard definition video properly, and also how to actually carry fast metadata to describe changes in streams very quickly. So those are all work in progress. And also that one over there on the right-hand side, on the middle one, how to actually interface compatibly with the composite format that's the legacy of 2022-6. So that's the suite of toolkit that we've actually developed for transport, and very specifically for transport. What we've actually also recently been doing, which is something that's been very much missing in the 2110 suite when it was originally developed, and I think similarly, although in not quite such a poor way, within the audio side as well, is the actual control plane, how we actually control those flows and actually do plug and play and assign and define things. And we've much more recently been maturing the NMOS specifications, which allow us to actually define the controller flows, be they the audio flows or be they the video flows in our system. Now, when talking to customers and doing designs, architectural designs for systems, there's quite a few principles that we've been coming across for audio that have been very important. Now, I'm not going to go through these in great detail, but just to say, there's a few things here that are kind of obvious, but have very much come into play. So first of all, let's avoid going back to baseband. Let's keep the workflow in IP. and actually some of the manipulation requirements in the audio domain, which I'm going to come on to in a minute, are actually quite complex. So we need to have the toolkit available to make sure that happens. And also some of those traditional things that we're very much used to in our audio workflows in terms of gain and delay adjustments are also still very important. We also are continually needing to reconcile what I call potentially rogue timing sources in the digital domain into our ecosystem in our studio, in our plant as we do production. So the sample rate converter is obviously in very much use there. We've also got a requirement which I'm going to talk about briefly later on, which is how we actually reconcile absolute time. So not just the actual the sample rate of the audio flows, but also how we reconcile the timing offset of those flows. Also within the 2110 suite, obviously like within AES67, we can actually have a very wide number of channels within flows, and we have within customers different mindsets that of people wanting to do how many channels of audio they want to have in per flow. We have some people that have the mindset they're going to break everything down to individual mono audios, because they can then do their, if you like, their shuffling just by manipulating IP flows. Some of us that are probably slightly more traditional would actually look to preserve things at least that have phase coherency requirements in a single group of AES 67 or -30. Orchestration is important, and the control plane, as we've just been talking about from the NMOS, and keeping that IP shuffling. The other thing is that the audio requirements is driving scale like nothing else. In traditional like SDI routers within plants, if we have kind of an 1152 squared SDI router, then each of those flows can be handling 16 audios as well as the videos. So that actually handles quite a lot of flows. Obviously, if we're breaking the audios back into maybe monos or stereos or 6s or 8s, depending on what we're actually carrying, the number of flows that we're actually dealing with is forever rising. One of the recent deployments in Europe we've been involved in has recently hit 43,000 flows. That's video and audio, but the bulk of that is audio. So that's just a sheer scale of stuff, and that actually means we have to have lots of things that scale well, not just the ability of our IP routers to handle that scale, but the ability of the control systems to do that. Talking about the flexibility within these architectures that we need, we actually have a lot of different formats that we are actually seeing as we do designs of new plant that we need to interface to. So we've got what I call native video associated audio that we're having to handle. So we've got traditional SDI that we need to de-embed audios from. We've got standard ST211030s, which may be groups of 8, maybe groups of 64 because we've transformed them from MADI. They may be stereo pairs or individual monos. We've got 2022-6, which is what I call our legacy IP SDI composite, where we've actually got to de-embed the audios from the IP that's in like lookalike SDI. We've also got other flows that are video related. Not only that, we've got a whole load of what I call pure audio stuff. So we've got MADI, which may or may not be coming in synchronously. Quite often is not, so we have to do sample rate conversion to that. We've got lots of bulk AES67s coming in. We've got native AES3 and analog, which we're still having to bring into the system as it stands. I talked about asynchronous. Certainly what we're seeing is, especially things like remote commentary houses, we're having digital flows coming in that are definitely non-synchronous to our plant. So we need to sample rate convert them. And then obviously we've got -30 and -31 flows that we need to accommodate. So we've got a plethora of different types of audio that we need to be able to manipulate, and each of almost all of these can have a different bus width and a different sample rate period and different parameters with it. So we actually have a massive requirement within our audio infrastructure to do a lot of different things. So we need to address manipulating the channel widths of AES67 or -30 flows. We're having to flip between probably 1 millisecond and 125 microsecond packet periods as we're going through the things. We have lots and lots of pieces of equipment in the studio facilities that only accept certain audio bus widths. So we have some things that are set up purely for groups of 8, some that need groups of 16, some that are set up for stereo pairs coming in, and typically we're having to reshuffle and rebuild new bouquets of channels that are actually maybe coming from various things. I've set this block diagram up here just to expand a little bit on some of those requirements as we see them. So we typically obviously have an event location, and if we're doing a full remote production which includes audios, what we're typically seeing is unusually MADI seems to have come into its own in recent years more than it did for like the previous 15 years. But typically we're seeing maybe 1, 2, 3 MADI flows that are carrying up to a couple of hundred different individual audio flows from a location. They need reconciling timing wise as we come into the plant to make sure they're synchronized. The remote commentary location gives us challenges as well, because typically those remote commentary locations have a couple of challenges. If they're coming in digitally, we need to reconcile them to the timing, but we also have a big challenge there in that the actual time that those take to actually go back and come forward is actually significant. And just expanding on that, in our workflow, typically these remote commentaries will be running on a proxy video that's being sent from the production. So you've got the production running in real time, you're creating a proxy which usually involves some compression which takes time, you're transiting that sometimes over public internet to the person to do the remote commentary, and then you're bringing that remote commentary back in real time and then needing to time align that into the workflow. So you could be talking about the order of a few hundred milliseconds of time offset in that workflow. So not only have we got frequency reconciliation, we've actually got a significant time offset. And also when that comes back in, typically we're actually seeing that needing to be groomed into a bouquet of flows that's actually going to go into some the next thing down the chain in terms of audio manipulation, for that to actually be groomed into maybe alongside other audios, some stereos that are coming in from elsewhere and other things from the event location or the produced audio that's been mixed without the remote commentary in it. So there's a whole load of requirements in terms of synchronization, time offset compensation, and compensating for timing domains. So that's, if you like, just looking at the event location and remote commentaries. When we're actually long hauling audio, there's quite a few other things to consider. Once we're going over long distances, there's not only have we got the issue we've already talked about asynchronous sources, we're actually into much bigger networks. Now, a lot of campus audio systems typically have been designed to work very well in a low latency layer 2 non-routed environment, but maybe are less well suited for an environment when we're going long distances, when we need to compensate for those things, and we need to allow and reconcile that. Additionally, in what we haven't here is what we also I haven't put in this list here, we need to typically protect signals more when they're in a wide area domain. A lot of audio flows typically so far haven't adopted the dual -7 RTP spatial diversity that we have deployed on most video flows to date. So we're having to look at how we actually engineer dual diverse routing and dual diverse flows for all of the audio as we go over wide area interconnect as well. So quite a few challenges for the audio ecosystems as we actually take them outside of the campus in terms of making them work in a holistic and distributed production. We also have another challenge that's part of the whole 2110 system now, which is how do we do end-to-end timing? One of the if you like golden ideas that we had as we did IP production systems is that as we actually developed IP workflows, we would be able to track time holistically through each of the individual essence paths through a production chain. So obviously the whole benefit of 2110 and having the audio video metadata separate is that it actually allows us to actually manipulate each of those flows and have them in their own workflows, which are obviously required. But as we look at these workflows and we subject each of them to different things, in the video workflow we may have an augmented reality production which actually is adding several frames of latency. We maybe have a vision mixer that's adding a couple of frames of latency. Lots of different elements in that workflow. The audio typically is going to have a lower latency path because it's got less stuff that takes a long time to do. And we want to reconcile them at the end. Now, the beauty of AES 67 and -30 by its very nature, and also the video elements of 2110, is the fact that our timing, the timing of the audio, the sample capture by the microphone or the video frame by the camera, is actually, that time is the absolute time of that is captured. And that's very, very good. That means our workflow has that. But if we look into this production chain that we then have, there is, by the very nature of the way most people, both in the audio domain and in the video domain, have implemented the processing devices that are downstream handling the audio, we're actually losing origination time as we go through pieces of equipment. And what that means is we don't necessarily have the ability at the far end, at the egress here where we're about to hand off, we don't necessarily have the ability to track time and to automatically reconcile the timing between and do the compensation of the different latencies that the different essences have been subjected to. Now, some of that is because a lot of equipment, both in the video domain and some in the audio domain, has like its traditional video or audio processing, and the IP interfacing has been a bolt-on onto the front and back end. What we're now seeing in design, which gives us the ability to track time, is a lot of equipment that's actually coming out where it's actually understanding the arrival time of the audio samples or the video frames, and it's understanding what it's doing in terms of its manipulation, and it's then allowing to egress or output that packet flow, being cognizant and compensating for the time that it's adding and incurring on that. So downstream equipment still has knowledge of what time, absolute time, origination time, each audio sample or video frame has associated with it. Now, AES 67 went some way to actually being able to track this with link offset, but that still doesn't actually provide us what we need for end-to-end. And one of the things in the one-year revision that we're doing on -10, part of the 2110 suite, is actually some additional recommendations that allow us to declare that we can track time, both in the audio workflow and in the video workflow and in the other metadata workflows, so that will allow us to actually reconcile those times as we go through. Another thing that I think we're actually learning as an industry is that we should be able to do good holdover as part of equipment design. So if I look at the digital audio guys, who, as I say, were the pioneers here and got there first, a lot of digital audio equipment still, if you remove the PTP reference, just mutes, because it doesn't do much of a holdover function. And one of the real things that we've been working with in PTP distribution and the way media process equipment handles PTP is actually getting holdover to work properly. Now, this applies to lots of different parts of the chain. That holdover applies to IP switches that are doing boundary clock functions where they're regenerating timing. It applies to video functions where we're actually doing video processing, and it applies to audio equipment that's doing audio processing. With modern NCOs, digital loops that we have within these equipment, there's no reason why we can't hold over timing for minutes or even hours and actually maintain good timing and avoid going into a position where we're actually not propagating information. So the way equipment behaves during times of problem with PTP, not that there should be any, is actually very important. It's something that the industry is maturing at the moment. This is a picture that I've been using a few times to talk about the delineation between our campus and our wide area networking when we're actually doing some of this going off campus to potentially another friendly or not so friendly environment at the other side. So there's lots of things that we actually rely on and know about within our campus. On the green side here, we have pristine timing. We have a good holistic timing model. We don't necessarily know what the timing is outside. We actually have, with the NMOS toolkit I talked about briefly earlier, a way of doing automatic device discovery and control and actually plug and play within the facility. Some of that we actually don't want to make available or needs to be securely controlled as we go off campus. We've got an IP addressing scheme which is being very well brokered within the facility, but as we go off net elsewhere, other people have got IP addressing schemes that we need to translate to. We also have typically in the facility, by the very design of 2110, the essences. We've got the -20, the -30, the -31, the -40 flows. As we go off net, sometimes we may be going to more of a composite 2022-6 type flow. And then what we have, what I call protection termination. This is the reconciliation of our 2022-7, our RTP merge technology. And we may have a different protection capability outside. We may also be in the wide area, be adding FEC as well. And just to break that down very quickly, these are some of the different protections that we typically are using off campus that aren't necessarily needed on campus. This spatial protection top left is something that we are using a lot, almost always for video flows and more for audio flows within campus. The temporal protection in the FEC is something typically we only do in the wide area network. I'd like to draw your attention to a piece of work that I've been chairing within VSF, which is called the 2110 over WAN. And what specifically we're working on is actually saying there's lots and lots of different points in production, meshed production as we're doing now between campuses, where we actually wanting to carry media essences, which includes the video and the audio, between facilities and all of the associated control elements, the standardized control elements between those campuses as well. We're wanting to do them in a standardized way and a fully secure way, so we're not compromising the way we work in either of those facilities, but we're actually able to do plug and play in terms of sharing facilities. Now, I'm not going to unpack all of that here because that's a talk in its own right, but I just want to draw your attention to this work. If you go to the Video Services Forum page, you'll be able to see that, or just Google it. There's a few talks that I've done online about it that you can see on YouTube as well. This just covers some of the stuff that we've been working on. This is a slightly out of date because we're pretty well, most of these have now got ticks in because we've pretty well finished the work. Just want to draw your attention to a couple of little elements here. One is the main one here is the trunking of the essences. So one of the things we face as we take these essences, the video and the audio and the other data flows, as we take them over wide area networks, is the different bandwidths we're talking about here. So that video flow at the top, maybe if it's an HD feed, is probably the order of 1 gigabit per second of bandwidth, uncompressed. If it's a UHD flow, it's more like 8 to 10 gigabits per second. If these -30s are individual mono audios, they're sub 1 megabit per second. And if that -40, which is carrying a little bit of ancillary data, that may be bumbling along at 100 kilobits per second. So very different bandwidths. And we have to be very careful as we go over wide area networking, especially as we apply things like FEC, that we actually don't introduce significant latency skew between these different flows because of the speed they're running at. So one of the concepts we've come up, which also helps service provider routing, is to actually trunk these flows together. So we're actually working on, as part of the standard, a way of aggregating those flows. So we actually have a trunk. We're actually using a technique called established standards called GRE and RTP to do that. So we actually have a tool which allows us to aggregate video, audio, and other stuff, as I put at the bottom there, which may be other associated UDP or even TCP flows that are associated with the production, which we can aggregate together to send together, so they're subject to the same latency, the same routing, and the same protection as they traverse the wide area network. One recent example that we've actually deployed in a big pan-European network that's just going live at the moment. It's been actually in test for the last 3 months. This is going across quite a few in the northwestern part of Europe, between the Netherlands, between the UK, between France, and a few other countries. This just shows you this essence is carrying, where we're actually carrying the 2110-30 flow separately to the vision and associated metadata, with dual diverse paths over the wide area network, which we're then healing as we get to the edges to actually provide holistic flows back into the other production campuses. So this stuff's being done, it works, and it works at scale, which is very exciting. Okay, we're nearing the end of my time here. Just thought I'd just give a few conclusions. As all of you guys know, it at the AES 19 symposium here, that the audio is incredibly important. It's always the most complicated part of any production process, to set up and to run, just because there's so much more of it, and we need to do so many different things with it. The full standards compliance is essential, and I specifically, in the audio plane, I'm addressing that to the control layer. Lots of people have done very good things in audio that are relatively bespoke to achieve plug and play. We need to move to a point where we've got a unified plug and play architecture that works between video and audio. And we've got the toolkit that now allows us to do that, which is great. We also need to make sure that all of the audio systems actually are capable of running layer 3, so we can actually run in a properly routed environment over multiple zones in multiple territories. Keeping everything IP is important, and to do that we need to have a phenomenal amount of audio manipulation that we're able to do within the IP domain, and we'd love to show you. We're actually Nevion's got an exhibition as part of the NAB stand just through there, and we've got a really good toolkit that also addresses quite a lot of these audio things, and we'd like to share with you some of the stuff we've done in recent deployments that helps us to address some of these. So hopefully that's given you some food for thought about a whole load of things that are audio related, and so hopefully you're going to have a really good show. Thank you for sitting and listening, and standing and listening. It's been great to share a little bit with you, and enjoy the rest of the show. Thank you. Oh, and I forgot to say, I'm from the UK, and we do really good cups of tea over there. So if you're ever over in the UK and would like a cup of tea, do check me out. These are my details here. They'll be on the presentation as well, so you can come and find me, or come and grab a business card from me now. Thank you very much. The booth is over in the NAB one, and I'm just going to, Luan, what's our booth number? Say again. 600 row in just through there. Do come and chat. It's at the far end of the NAB exhibition. Thank you very much, everyone.